Bum bum bum. La 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 la. Science, 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 science. Part 2. All right. Let's get this started with. Tectonic plate under Tibet may be splitting in two. This is a pretty darn interesting story because of how unlikely it seems to be. Now, apparently, there's this peeled apart Indian plate that could be affecting earthquake hazards. Now, the towering peaks of the Himalayas are a geological battleground, a slow motion collision of the Indian and Eurasian tectonic plates. The crunch began some 60 million years ago as India, then an island, plowed into Eurasia, buckling the surface and forming the highest mountains on Earth. But the peaks are just the noise and the smoke of the battle, and the tectonic maneuvers tens of kilometers below them, the drive, the crash, and they hold mysteries. Now, the continental tectonic plates, unlike their dense oceanic cousins, are actually thick and buoyant, and so they don't easily sink or subduct into the mantle during collisions. Some scientists actually believe the Indian plate resists plunging into the mantle and continues to slide horizontally under Tibet. Others suggest that the most buoyant part of the Indian plate rumples like a rug along the front edge of the collision, making it easier for the lower half of the plate to sink into the depths. Now, a new analysis of earthquake waves actually traveling beneath Tibet and telltale gases are starting to rise into the surface, and to yet another possibility, one in fact that it splits the tectonic plate in two, boom, 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 making it a new tectonic plate. And so, as it slides into the Eurasian plate with the dense bottom part peeling away from the top, and the study also finds evidence for a vertical fracture or tear at the boundary between the peeled apart sections of the slab and its intact neighbor. Intact neighbor. These scientists actually didn't know the continents could behave like this, and is for solid Earth science pretty fundamental. And apparently, all of this is actually nothing new. It's just that it's rare. Now, of course, it's like the data is limited, of course, it's a snapshot, but it work is an important step towards understanding how modern landscape came to be. And he says, and the person who wrote this says, it's definitely the type of work that they need to do to move forward. Next up, ancient DNA ties modern diseases to ancestry. So here we go. Among Europeans, risk of multiple sclerosis rises with genes from the Bronze Age Yamnaya herders, and by Andrew Curry. So, like many diseases, multiple sclerosis hits some populations harder than others. For example, Scandinavians are an estimated 17 times more likely than people from sub-Saharan Africa to develop the devastating chronic disease, in which the body's immune system attacks nerves. And it's pretty puzzling, says says this guy from the University of Copenhagen, paleogenist and S.K. Willerslefs. Some have actually speculated that Viking genes or some aspects of Northern Europe diet or environment might actually boost risks. Now, new data from ancient skeletons actually show part of the answers arose in the Bronze Age. About 5,000 years ago, people from the steppes near the Black Sea, whom archaeologists call the Yamnaya, moved west across Central and Northern Europe. In Scandinavia and parts of Northern Europe, these mobile cattle herders took just a few centuries to largely replace the sedentary farmers who had tilled the soil with stone tools for millennia. And the Yamnaya brought with them not just like a little different way from life, but apparently also a bunch of different diseases too. Also, it turns out that whatever disease you get actually also depends from your heritage. Apparently, sometimes you're born with immunity, sometimes you just have to make it up yourself. So apparently DNA has a pretty good thing to do with this. Ancient DNA ties to modern diseases to ancestry. Apparently, that's pretty true. This is paleogenomics anyway. And with the UK Biobank, a massive DNA set of health histories and DNA from more than 430,000 modern British people, and the comparisons actually reveal how the proportions of an ancestry from ancient populations predicted differences in disease risk and the physical attributes such as height and body mass in the present-day Europeans. Wow, man. Wow. That's pretty good. And I'm not gonna go on because then this would go into like a bunch of things, and then I don't want to go in there. Alright, next up we have COVID's cold cousins. So, 4 largely ignored coronaviruses circulate in humans without causing great harm and may portend the future for SARS-CoV-2, meaning COVID-19. Now, over a few weeks in November of 1889, a respiratory disease attacked half the residents of St. Petersburg, Russia! And it soon began to race through Europe and the rest of the world. And 2 years later, the spectacularly detailed book, a British medical officer, H. Franklin Parsons, described what was the Russian influenza epidemic, and which raged until 1894. And people seemed to spread the disease before developing symptoms. The young did not suffer as much as the old. A dry cough was common among the ill, and some had pervasions of taste and smell. And deaths rose, and suspicions ran high that the pathogen had jumped from an animal into humans. Does this sound a lot like COVID-19? And then in 2005, scientists in Belgium proposed that the earlier pandemic's cause was not to an influenza virus, but rather a coronavirus. 3 years before their theory was actually published, a coronavirus had passed from animals to humans, touching off a highly lethal outbreak of what was called severe acute respiratory syndrome, SARS, which is why this COVID-19 is called SARS-CoV-2. So apparently there's actually a lot of things too. There are cold coronavirus, like natural reservoir host, and there's an immediate host, and there's like a human virus which is discovered, like those kind of things. And then like other things that are happening too. But sometimes we have literally no idea what it is. We may have the animals that suspects, but we have no idea which it is. And then there are also killer cousins, which come from like 2003 to all the way to 2020. And this is pretty bad. Also, we can actually treat these. Like, luckily, we can treat these. And apparently, this is also where the influenza actually comes in to play. But there's not much I can actually guarantee and say. So, next up, insights. Decoding the language of immunity. Nah, we're not going to do that. What we're actually going to do is talking about electrons catching light pulses on the fly. Boo! Now, energy exchange between electrons and photons actually enables ultra-fast probing of materials. Okay, maybe I should just do the immunity. Yeah, no, what? I'm gonna stick with this. Also, free electrons are widely used as probes to analyze the morphology, atomic structures, and optical properties of nanoscale materials. Using these transmissions or scanning electron microscopy, they can also interact strongly with light and thus sample the distributions of optical fields in and around those materials with high spatial resolutions. Specifically, in photon-induced near-field electron microscopy, intense light fields bringing an electron into multiple energy states simultaneously on a quantum mechanical superposition state, which are then measured with like an electron spectrometer. On page 168 of this issue, Yang et al. Reports the use of like PNM to examine the creation of a special in an optical integrated circuit, and the electron-solution interaction shapes the electron's probability of distribution on space and time, thereby enabling new ways to probe ultra-fast dynamics in matter with an electron microscope. Wow. So basically, there's like something flying, an electron gets shot, it hits the thing, and it comes back, we measure it. It's like me when I threw a frisbee and it accidentally hits a butterfly. That happened 3 days ago at school, and it was creepy. Someone stepped on the butterfly afterwards. Yeah. I'm the cause of that butterfly's death. R.I.P. butterfly. I will go to hell. So next thing that actually going to happen is like how this electron actually catches light pulses on the fly. So it just happens. You like aim. It's that simple. At least that's how it makes it seem. But then I'm not actually going to say any more because then I'll become more confused. I'll confuse you and lots of other things will happen. So I guess we'll have to wait until this for next time. So until next time, my dear friends. Adios, amigos. Bye bye. And wear a helmet.